The exam is Friday. So the exam is Friday, November 4th. You can start anytime from 11 a.m. to 3 p.m. So I'll be in at 11. You don't want to get in later than 3 because you want to make sure you have time. If for some reason it has to be later, just let me know that you're coming in later so I remember that. But that's fine. If you'd like to take it the day before and not have to worry about it on Friday, I have a couple people taking it Thursday at 9 a.m. I could also do 7 p.m., but I don't have anyone scheduled. So if you're thinking of coming at 7, let me know so I remember to turn it on and give you the password and everything. But I do have people coming at 9. So if you'd like to come at either of those, that's fine. Or Friday at 11 a.m. Well, 11 to 3, somewhere in there, you just get in. Any questions on that? I changed one of the, well, I didn't change it. I just took the derivative out of it. So there's 2 derivatives, there's 1 explanation, and then there's 3 applied problems. The applied one, the explanation one is, how are critical numbers formed and why are they important? So I had a problem where you had to take the derivative and set it equal to 0 when you're finding the slope of the tangent line is horizontal. I took that part out because it was just another derivative and setting it equal to 0 that you didn't need to do. Because with only 50 minutes, I didn't want you doing a simple derivative when the main thing I wanted was to make sure you knew this. So how are critical numbers found? Anyone? Take the derivative. Set it equal to 0 and solve. Setting the derivative equal to 0, exactly. Why are they important? What do the critical numbers give us? Think about the graph. It gives you the highs and lows on the graph. It's where the relative max and mins are. So the critical numbers tell us where we have highs and lows in our graph. So you could say highs and lows or relative max and min, whichever one you think of at the time. So this is the explanation problem. From the in-class portion. We want to study 2, 3, 4, and 6. Then this is the explanation one. And the other one is on the outline. And we did it last class, this one. So 2, 3, 4, and 6, be able to explain this. And then this is the other problem. And we did all of them last class. production level. One of the problems, you have to find the production level. Number 6. So you have to find the production level. The production level is from the average cost function. Average cost is the function divided by X. So to find the production level, you will first have to find the average cost function. Once you find the average cost function, the derivative of that, and setting it equal to 0, critical numbers are production level. Any questions on what the production level tells you? Because this one will ask you to find the average cost function, the production level, the minimum average cost, and why it's important. So the production level is important because that tells you how much you want to produce at a time to have a minimum average cost. So production level tells you how many you should produce to have a minimum average cost. Once you find that production level, to find the minimum average cost, you just plug it into the average cost. Any questions on that? So there's 2 problems where you need to explain. One is just this one, and then the other one is once you find the production level, you have to tell me what it is, what it means. Any questions on that? You always take the derivative if it says marginal revenue, profit, or cost, instantaneous rate of change, slope of the tangent line, all those mean derivative. So if you get to the test and you're like, I don't know where to start, take the derivative. Other than where you have to find the average cost first, they all need the derivative. Any questions? For a formula sheet, you could put this one. You could put production level is the average cost derivative set equal to 0 if you want. And then the derivative ones, we've learned pretty much 3. Product rule. That's when 2 things are multiplied together. And we learned it by first and second. So you have your first quantity times your second one. That means the derivative then is the first times the derivative of the second plus the second times the derivative of the first. Quotient rule. That's the fraction. Top and bottom. So the derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And then the power rule. F of x equals ax to the r, if you want. And what you do is you multiply and then subtract 1. So the derivative is a times r x to the r minus 1. And I guess one more if you want the constant rule. But I think everyone knows that one now. If f of x is any constant, any number, the derivative is 0. So you can have all of those rules written down on a formula sheet if you want. Any questions? So for the in class, we did all of them last class. In both videos, this class and the one before are up there. But is there any you need to see more of from the in class? I think you should be fine. The biggest thing is knowing the derivative. When you see something, you should be able to quickly know the derivative. That way, then you can finish the rest of the problem. But there's only 3 that are applied. Any questions on that? On the take-home exam, I wrote what numbers they're similar to. Like if you go to the My Math Lab, the take-home portion. This one is similar to number 5. And in my other class, we were talking about it. This just means derivative. Critical number, set it equal to 0 and solve once you take the derivative. Now, when you're finding the max or min, this one gave you endpoints between 4 and 20. So you only take the critical numbers that are between 4 and 20. And check all of those values. And we want the maximum, so you take the largest S of X value. That would be your maximum. So it will, you need to show your table. It's part of the points. This on the end here is just how many points the problem's worth. So this whole thing is 6 points. Number 2 is similar to My Math Lab number 4. Find the derivative using the product rule. First times the derivative of the second plus second times the derivative of the first. And then on this one, you want to FOIL it first and then take the derivative, show they're the same answer. This one is from the outline. And under Media Gallery, I did this one from the outline. So I did this problem, it's under Media Gallery, and I did this one, and I did 7B. So these 3 are under a Media Gallery. And it'll say 3, 8, and 7B. Yeah, so this one, again, you take the derivative. Instantaneous rate of change means derivative. Critical number, set the derivative equal to 0. It's only going from 1 to 12, so you take any numbers that land between 1 and 12 and 1 and 12 and check them in the f of x. And we want the minimum, so then you take the smallest value. So this one wanted maximum, you take the largest. This one wanted minimum. And this one's similar to number 1 on My Math Lab. This one's similar to number 2. Any questions on those derivatives? Number 6 is similar to number 6 on my math lab. Number 7 is similar to number 3. And then number 8 is similar to the outline problem, which is in the media gallery. But if there's any you want me to do, I'll do them. But that way then you know where they correspond, so you know what to look at also. I think the hardest problem is this one. We did 2 of them. Probably Friday last week. I think it was Friday. It was Wednesday or Friday, but I think it was Friday. Is there any that you need to see? Really? And show the first one. So this one? Or the first one on my math lab? Okay. So this one is similar to number 5 on my math lab right here. So the first thing on my math lab, it would ask for, on our test. That's the derivative. So whenever you see this, it means to take the derivative. Multiply 3 times the number. Zero, zero, 6, 5, 1. Times 3. So we multiplied by the 3, and then we subtract 1 and get 2. Then we multiply by 0.1915 times 2 is 0.383. And then t, when you subtract 1, will be to the first power. And then 1 times this is a negative 1.071. T to the 0 drops off, and this goes to 0. That would be the first part, the derivative. The second one, to find the critical numbers, you set this equal to 0 and solve. Now you could use the quadratic formula if you wanted. Definitely not going to try and factor it. Another thing you could do, the one on the test, the numbers are a lot nicer. And it's factorable. But this one didn't come out so nice. So what I would use is Desmos. Because we're setting this equal to 0, if we look at where it hits the x-axis, that's the values where it's 0. So you could just plug the equation in. Y equals a negative 0.019542 x squared plus 0.383 x minus 1.07. Now notice we're not seeing where it's coming back down, so you could just zoom. There we go. And you want where it hits the x-axis, because that's where y is 0. So we have two answers. 3.379 and 16.22. So it's another way of finding your critical numbers, because instead of using the quadratic formula, we're just looking at the graph. Does the same thing. Just make sure you're only taking where it hits the x-axis, because y is 0. So this would be your critical numbers. See if this one's asking for. I think they're keeping the decimal. Normally I ask for whole numbers. Any questions on that part? And then it says that it's between 0 and 24. So on the test, I will ask you to find the max or the min. And we'd use 0, we'd use 24. And then in this case, our critical numbers are both between 0 and 24. So we'd use both of them. And you plug them into the original. So right here's the original. I couldn't find one with nicer numbers online. I don't know why. Yes, the table you can do on Desmos also. So what you could do, let me move this over a little bit. We'll delete this. And then right here where the little plus is, you can go to table. Now this is X1. So then here, instead of Y1, you want to put the equation. The original right here. But instead of T's, you're going to put X1 because this is X1. Negative 0.006514. And then for the 1, you click X. When you push 1, it automatically goes down. You don't have to worry about the subscript. And then for cubed, you click on this A to the B and put your 3. And then use the right arrow to get back down. That's this one. Plus 0.1915. X1 squared minus 1.071 x1. The biggest thing is making sure you remember your ones with your x's. 1868. Okay, so you enter your equation. And then you put your values here. We had these ones. So 0, 3.379. And 24. The highest is the absolute max. So if we needed a max, it would be 23.9. If we needed a min, it would be the 13.2. So anytime you have to do a table, you can write it on here. Still put it on your test so that I know you did it. That way you don't have to worry about attaching Desmos. You can just put it here. I will be, part of your grade is that the table is there, so make sure you show it. Any questions on that? Any other ones? Is everyone okay with, remove this? Is everyone okay with this one? Okay, any that you need to see? We're good with everything else? A couple people turned the take home in already, which is nice. Any questions on any of them? Okay, when you start them, especially like number 6 or number 8. If you want, when you set up the revenue, if you want to send me a picture first and see if it's correct before you do everything else, you're more than welcome to do that. Any questions on anything? You're so quiet. Okay, if you do not have any questions, then I will see you on Friday or Thursday if you decide to do it early. Any questions?